it's going to be smarter. There are all of these other things, we can talk about. It'll be better at these kind of tasks. It'll be multimodal. It'll be faster. Who knows what. The thing that I think really matters is it's going to be smarter.
Is LLM System 2 thinking unlocked by GPT-5? Large language models like GPT-4 have impressed us with their ability to generate text, demonstrating the advancements made in AI in recent years. But these models mostly rely on System 1 thinking, which is quick and straightforward, but unable to investigate alternative solutions and deconstruct complicated issues into smaller chunks. Because of this constraint, researchers are concentrating on creating a more reliable and strong GPT-5. In Thinking Fast and Slow, Daniel Kahneman presents the idea of two distinct ways of thinking, System 1 and System 2. Our quick thinking, intuitive brain, or System 1 thinking, generates responses swiftly using knowledge we have committed to memory. Conversely, System 2 thinking is more deliberate, but slower. It necessitates that we take our time, make calculations, and conduct analysis before coming up with a solution. Similar to this, System 1 thinking is the main method used by huge language models like GPT-4. Without really comprehending the intricate difficulties they are attempting to solve, they make predictions about the ideal words to say next based on word sequences they have already seen. Though incredibly powerful, GPT-4 lacks System 2 thinking. It is not able to investigate other solutions or divide up difficult jobs into smaller pieces. All it does is produce text by applying patterns that it has learned from training data. This shortcoming becomes apparent when GPT-4 encounters challenging situations that call for more thorough thought and reasoning. In a Veritasian film, for instance, college students were asked things that seem straightforward, such as how long it takes for the Earth to orbit the Sun. Because they relied on system thinking and gave automatic, intuitive replies without really thinking about the question, many of them gave the wrong answers. GPT-4 and other large language models encounter a similar problem. They are incapable of using critical thinking skills or decomposing difficult issues into smaller, more digestible chunks. The goal of GPT-5 is to introduce System 2 thinking and improve the reasoning capabilities of huge language models. Sam Altman of OpenAI stated in a Bill Gates interview that reasoning ability and dependability will be the main GPT-5 benchmarks. As of right now, the GPT-4 is unreliable and has incredibly limited reasoning capabilities. It might give accurate responses, but it isn't always able to determine which is the best. By improving reasoning skills and reliability, GPT-5 seeks to improve this. Altman also alludes to the potential for GPT-5 to apply transformations an infinite number of times in order to solve challenging mathematical equations. This would surpass the capabilities of GPT-4 and necessitate a more sophisticated control logic for thinking. Prompt engineering and communicative agents are two typical approaches to encourage system thinking in large language models. One popular and straightforward technique for encouraging System 2 thinking in large language models is prompt engineering. One method is called chain of thought, in which a sentence is gradually added before the model produces any text. This compels the model to divide the issue into manageable chunks and consider each one separately. An alternative method is to offer a few, succinct instances of prompts in place of a whole procedure. These illustrations direct the model to examine various options and deliberate through several processes. Prompt engineering has limits but can be useful in encouraging system thinking. Often, it confines the model to a single solution and might not investigate other options, akin to how people tackle creative problem solving. More sophisticated prompting strategies, such as self-consistency with the chain of thoughts, have been suggested to get around this restriction. It entails iteratively going through the thought process, evaluating the results, and selecting the best logical response. This necessitates greater implementation work, but permits some study of other solutions. The tree of sorts is a more sophisticated prompting technique that mimics a tree search to examine various possibilities and paths. It records every path that has been taken and permits retracting steps if the present route does not result in the intended results. By putting the tree of sorts into practice is difficult and takes a lot of work. An elegant way to encourage System 2 thinking in large language models is through communicative agents. Users can define various agents in these multi-agent setups and simulate dialogue between them. The agents are able to reflect on and identify shortcomings in one another's viewpoints and methods of thought. It has been demonstrated that communicative agents can improve System 2 thinking. They enable committed agents to examine and comment on the model's responses, pointing out errors and offering suggestions. This cooperative method intimidates how people explore various solutions and gain knowledge from one another to tackle complicated challenges. There are several frameworks available for setting up communicative agents, including ChatGPT, MetaGPT, AutoGen, and Crew AI. These frameworks make it possible to create agent workflows and to have discussions between agents that do diverse tasks, including reviews and issue solvers. Workflows for communicative agents can be built up more easily with AutoGen Studio, a no-code interface for AutoGen. Its ability to provide seamless cooperation and issue resolutions across agents renders it usable by a broader spectrum of users. Prompt engineering and communicative agents can be employed to impose System 2 thinking and perform complex problems, even though GPT-4 may not have innate System 2 thinking capabilities. Prompt engineering, like the chain of thought or self-consistency with the chain of thought, directs the model to approach challenges methodically and take into account a variety of options. On the other hand, rapid engineering could restrict experimentation and a variety of approaches. Conversely, communicative agents offer a cooperative method of problem solving. Users are able to take advantage of the advantages of both System 1 and System 2 thinking by modeling discussions between agents. Reviewers are able to identify errors in the model's solutions, and problem solvers are able to refine their solutions in response to criticism. Communicative agent workflows can be quickly set up with frameworks like AutoGen Studio, facilitating smooth problem solving and collaboration. With GPT-5, System 2 thinking in huge language models could be unlocked. GPT-5 seeks to close the gap between System 1 and System 2 thinking by improving reasoning skills and reliability, allowing models to tackle difficult situations more successfully. Scientists are currently working on enhancing the GPT-5's reasoning capabilities. The goal is to empower massive language models to deconstruct complicated jobs, investigate alternative solutions, and arrive at more precise and knowledgeable conclusions. It's critical to keep investigating and putting into practice techniques like communicative agents and rapid engineering in order to promote System 2 thinking in large language models, even as we anticipate the development in GPT-5. We're starting to witness a change in how LLMs like GPT-4 approach challenging tasks as developers. That's all for today. If you like this video, please give us a thumbs up, make sure to subscribe to our channel and hit the bell icon to receive notifications. Also, express your valuable thoughts in the comment section below. Until then, bye. Also, spend some time watching other videos on the channel.